Today in Capechi's Corner, we're going to look at arc lengths and areas of sectors. When we look at a circle, we can see that the measure of arc AB is shown as x, and that would be in degrees. Now that doesn't go all the way around the circle, that's just part of the way, so it's just going to be a part of the circumference. Now depending on what that central angle is, that's going to depend on the fraction or the part of the circumference. So once we figure that out, we will take that fraction and multiply it by our circumference, and that will give us the length of arc AB. We'll use a similar idea when finding the area of sector AOB. Now, a sector is like a part of the pie chart. So if I'm trying to find the area of sector AOB, it's like I'm finding the inside. I'm finding part of that circle. So again, the first thing I need to do is figure out what percentage or what fraction of the circle I'm talking about, or I say the chunk of the circle. And again, x will be that central angle. And I'll multiply that fraction by the area formula, pi r squared, in this case to find the area of sector AOB. Our directions say find the length of arc AB and the area of sector AOB. So the first thing I like to do is first figure out what percentage of this circle I'm talking about, what fraction. Because I know that the whole circle is 360, I know I have 60 over 360. So when I simplify that, I'm talking about 1/6 of the circle. So I'll use that 1/6 both when I'm trying to find the length of arc AB and when I'm trying to find the area of sector AOB. Now remember, when I'm trying to find the length of AB, I'm trying to look at the circumference and figure out the fraction that I'm dealing with there. So we already found out that I'm dealing with 1/6 of the circle, and I'm going to multiply that by the formula for circumference, which is 2 pi r. 2 pi and my radius is 5. So I'll simplify that, and I have 10 pi over 6, which simplifies further to 5 pi over 3. So that's the length of arc AB. Now I'm trying to find the area of sector AOB. Again, I'm talking about that inside piece. I'm talking about this piece right in here. I want to find the area of that. So I'm going to take 1/6 because I know that that is the fraction, the percentage of the circle that I'm talking about. And I'm going to multiply that by pi and then my radius squared, which is 5, so 5 squared. So when I simplify that, I get 25 pi over 6, and that's my area of the sector AOB. In our next circle, we have a big diagram here. We have circle ABC. Arc AB is 120. The radius is 9, and we're going to find a few things. The measurement of arc AB, that's going to be 120, right? Because the central angle there is 120. We have the arc we're given is 120. The measure of arc ACB, so that's a major arc. So we're going to take 360 and we're going to minus 120. So that arc has a measurement of 240. Now when I'm looking at the length of arc AB, again, I have to figure out that what percentage is what fraction. So that's 120 over 360, which gives me 1/3, so I'll use that fraction. So I have 1/3 times 2 pi, and the radius is 9. So when I simplify all of that, I have 6 pi. So that's the length of arc AB. I'll do the same thing for D, the length of arc ACB. So again, we said on the previous question that we have 240 degrees. So 240 over 360, that will simplify to 2/3. So I'm going to use that fraction. Now in double checking my work, that makes sense because I have 2/3 for arc ACB and 1/3 for arc AB, and they do compose, when I put them together, an entire circle, so that when you add them together you get 1, which is exactly what I want in this case. So the length of arc ACB would be 2/3 times 2 pi, and again our radius is 9. So when I simplify all of that, I'm left with 12 pi. So that's the length of arc ACB. We'll finish up by finding the area of sector AOB, again what's inside there. So I know AOB again is 1/3 of the circle times pi r squared, pi, and then my radius is 9. So when I have that 9 squared, I end up with 27 pi. So that's the area of sector AOB. Now, if I'm looking at the area of the unshaded sector, again, we talked about the fact earlier that that makes up 2/3 of the circle times pi, and again, 9 squared. So that equals 54 pi is the area of that unshaded sector. In our last problem for today, we're going to find the area of the shaded region bound by segment XY and arc XY. So again, when we say bound by, we're talking about defined by. So we're talking about that area right there. Now, I don't have a specific formula for that, so I have to deal with what I know. I definitely have a right triangle there that I'm going to work with. I can find out the area of the sector, so that's kind of where we're going to start. So let's first find the area of the sector. So the area of the sector YOX. Now again, we have a 90 degrees, so I know 90 over 360, that's a quarter of the circle. So I'm going to take 1/4 times pi r squared. My radius is 10. So when I simplify that, I have 25 pi. So that's in the entire sector. But I don't need the entire sector. I just need that little piece. So I need to subtract out the area of triangle YOX. Now again, I can say the area is equal to 1/2 times my base, and my height are actually going to be the same because YO is a radius, and I also have XO here as a radius as well. So my base is 10, and my height is also 10. So the area of that triangle is 50. Now again, I'd have to be careful there. I could do a lot of different variations. I could have a 30, 60, 90 there. When I'm trying to find the area of the triangle, I have to definitely pay attention to the measurements that I'm given. So I'm going to take the area of the sector, the entire thing, and then I'm going to subtract out the area of the triangle because I don't need that. That's not shaded. So the area of the shaded region bound by segment XY and arc XY is going to be 25 pi minus 50. And again, that would be units squared because we're talking about area.